So now we're going to talk about measures of variability. Earlier, we were talking about center as a reference point, and it's important to have reference point because we want to find out how dispersed data is. But now, with the measures of variability, we will be able to actually solve for that dispersion of data. We have 4 measures of variability: range, sample variance, standard deviation, and coefficient of variation. Let's start with range. Range is the difference between largest and smallest observation. So what you do here is you only get the highest and the lowest number. You find the difference, and that's the range. So for example, if the highest number is 9 and the lowest is 3, you subtract 3 from 9, or 9 minus 3 is equal to 6. So 6 is how dispersed data is. Do not be confused between range and mid-range. Mid-range is about finding the mean using the highest and lowest number, while for range, you're only finding the difference between the highest and lowest number. Next would be sample variance. Sample variance is a mean squared deviation. Since mean is a balancing point of the distribution, the sum of differences becomes 0 and doesn't give a useful measure of variability. To resolve that, sample variance squares the difference. So recall earlier, we said that for mean, in order to find out that it is the balancing point, we use the equation summation of x minus x bar. With x minus x bar, we're ultimately looking at how far one data is to another. So if you recalled earlier with the example 8 and 32, and we find out that mean is 20, and we also found out that the difference between these values is 12. But then, of course, we also know that when you add up all of these differences, it becomes 0. And so sample variance would want to correct that by adding the squared. So we now have summation of x minus x bar squared, and we divide it by n. So there could be different formulas depending if you are working with sample size or population. So summation of x minus x bar squared over n minus 1 is used for population. So if you're not familiar with population versus sample yet, population means including all of the data values or items available, while sample is only a subset of the population. So for example, if in a country there are 100,000 people, that is population. But then when you want to have a respondents of only 500 people, then that's only a sample size. That is a subset of the population of 100,000. So let's try solving using the same example that we had earlier, 8 and 32. And we're going to use the sample variance formula. Remember that the mean earlier was 20. Sample variance is connoted by the symbol as squared. So we have 8 minus 20 squared, 32 minus 20 squared, all over the n, the number of items that we're dealing with, which is 2. This refers to 8 and 32. We have the answer 144. So 144 is the variance, or how dispersed the data is. Related to sample variance would be standard deviation. Standard deviation is a single number that helps us understand how individual values in a data set vary from the mean. And the larger the standard deviation is, the more dispersed the data. In sample variance, it is connoted by the symbol s squared. So remember that you still square the data. With standard deviation, we're going to remove that. And so in standard deviation denoted by s or sigma, and so s is used for sample and sigma is used for population. So let's say we're going to use sample size. Our formula would be the square root of the summation of x minus x bar squared all over n. So if you remember earlier in our example, our sample variance is 144. Now we're going to remove the squared effect for it, so we're going to get the square root of 144. And so the square root of 144 is 12. This is how dispersed the data is. Okay, so just going back, we remember that the average or mean is 20. And so when we lay down all of the data values, including the mean, we have 8, 20, and 32. And remember that the difference between the data values and the mean is 12. And we also found out that the standard deviation, denoted by S for sample, is 12. And so it fits, it makes sense now. The mean shows you the center, and now the standard deviation is showing you how far exactly the center is from the different values, or how far these different values are from the center. Now we have the coefficient of variation. It is used to compare dispersion in datasets with dissimilar units of measurement or dissimilar means. For standard deviation, the unit of measurement that you are going to use is the unit of measurement of the raw data. So if you use inches, you use inches also for standard deviation. And so coefficient of variation helps you be more standardized in showing this dispersion of data. And so it expresses standard deviation as the percentage of mean. And the formula for it is coefficient of variation equals standard deviation over mean. And you always have to be careful whether you're using sample size or population size, because it could be using population standard deviation, but you're using sample size for the mean. It's very important to know the difference, because later on when we proceed to different topics, we will have to be keen about knowing if it's a sample size or a population size. Recall earlier what I said about standard deviation, that the unit of measurement it uses follows the unit of measurement of the raw data. And it becomes challenging when you want to compare different standard deviations, but you're not using the same unit of measurement. In mathematics, we always need to standardize it to make it comparable. In meme culture, the standard unit that is often used is bananas. So whether you are trying to measure the height of the building, the length or the width of the table, or even a volume of something, they use bananas as a scale. It's a standardized unit of measurement for them. For statistics, the standardized way of finding the dispersion of data and making it more comparable to different data sets is by looking at the z-score. Z-score is a general approach to identifying unusual observations, to redefine each observation in terms of its distance from the mean in standardized deviations to obtain standardized data. It is the number of standard deviations as a given data point lies above or below the mean. So z-score wants to standardize the unit of measurement, and now instead of using the unit of measurement of the raw data, it starts to use standard deviation as the new unit of measurement. The formula for z-score is x minus mean over standard deviation. Now let's talk about the empirical rule. For data from a normal distribution, we expect the interval mean plus minus standard deviation k to contain a known percentage of data. And so it is understood with the empirical rule that 68% of your data values lie within one standard deviation away from the mean. 95% of the data lie within 2 standard deviations from the mean, so it could be plus minus 2, and 99.7% of the data values lie within 3 standard deviations from the mean. And all the data values that are outside the boundaries of 3 standard deviations from the mean is already considered as an outlier.